When people begin working seriously with large language models in professional environments, one of the first challenges they encounter is that the same model can produce dramatically different outputs depending on how the prompt is written. Two prompts that ask for the same information may produce answers that vary in tone, depth, clarity, and reliability. This variability is not random. It reflects the probabilistic nature of language generation and the enormous diversity of writing styles present in the data used to train modern models. Because of this, one of the central skills in prompt engineering is learning how to control the tone, style, and voice of AI outputs. To understand how this control works, it is important to remember that large language models are fundamentally pattern imitators. During training, the model is exposed to vast amounts of text written in many different voices. Academic papers, news articles, technical documentation, conversational dialogue, marketing copy, legal analysis, and educational materials all appear in the training data. Each of these domains has recognizable linguistic patterns. Academic writing tends to use precise definitions, cautious claims, and structured argumentation. Journalism emphasizes clarity and narrative flow. Marketing language often uses persuasive phrasing and emotional cues. Technical documentation focuses on procedural clarity and structured explanation. When a prompt is given to the model, it acts as a signal that activates certain patterns within the model's internal representations. If the prompt resembles the language used in technical documentation, the model will tend to produce a technical explanation. If the prompt resembles a casual conversation, the output will likely be more informal. In this way, tone and style emerge as statistical consequences of the prompt context. Controlling tone begins with recognizing that tone is not a separate feature added to the text after it is generated. Instead, tone emerges from the linguistic patterns that guide token prediction. Every word choice, sentence structure, and phrasing pattern influences the tone of the output. Therefore, the prompt must establish the desired tone from the beginning. One effective way to guide tone is by explicitly describing the intended communication style. For example, a prompt may request a formal explanation suitable for an academic audience, or a friendly explanation suitable for beginners. When such instructions are included, the model can align its output with the statistical patterns associated with that type of communication. Another technique involves specifying the audience for the response. Tone naturally adapts to audience expectations. An explanation intended for experienced engineers will use different vocabulary and sentence structure than one intended for high school students. When the audience is clearly defined in the prompt, the model can adjust its language accordingly. Tone control also involves the level of assertiveness in the response. Some contexts require cautious language that acknowledges uncertainty and limitations. Scientific writing often uses phrases that signal probability or conditional reasoning. Other contexts may require confident and directive language, such as instructional guides or operational procedures. By specifying the desired level of certainty or authority, prompts can influence how the model frames its conclusions. Closely related to tone is the concept of style. While tone refers to the emotional or interpersonal quality of the writing, style refers to the structural characteristics of the text. Style includes factors such as sentence length, vocabulary complexity, use of examples, level of technical terminology, and narrative flow. Language models can adapt to many different styles because they have been trained on diverse forms of writing. Prompt designers can leverage this flexibility by describing the style they want the model to emulate. For instance, a prompt might request concise technical writing, detailed explanatory prose, or storytelling-based explanations. Style control becomes especially important in professional environments where consistency across outputs matters. When AI systems generate reports, summaries, or documentation, inconsistent style can reduce readability and credibility. Carefully designed prompts can help ensure that the generated text follows a predictable stylistic pattern. Another dimension of output control is voice. Voice refers to the persona or perspective from which the text appears to be written. In human writing, voice reflects the identity of the speaker or author. In AI-generated text, voice emerges when the prompt frames the response as coming from a particular type of expert, professional, or communicator. For example, Asking the model to respond as a systems architect encourages a different voice than asking it to respond as a science educator. The systems architect voice will likely emphasize architecture diagrams, trade-offs, scalability concerns, and implementation constraints. The science educator voice will emphasize conceptual clarity, analogies, and pedagogical progression. Voice control is particularly useful when the goal is to align the output with the expectations of a specific domain. Technical documentation benefits from an authoritative yet precise voice. Educational material benefits from a supportive and explanatory voice. Analytical reports benefit from a neutral and evidence-based voice. It is important to understand that the model is not actually adopting an identity in a literal sense. Instead, it is activating linguistic patterns associated with how people in those roles typically write or speak. These patterns are encoded in the training data and can be triggered by the prompt. Tone, style, and voice together shape the communicative character of the output. They influence not only how information is presented but also how the output is perceived by readers. In many professional contexts, the difference between an acceptable response and an excellent response lies not in the information itself but in how that information is communicated. However, controlling tone and style is only one part of prompt engineering. Another equally important consideration is the length and complexity of the prompt itself. Prompt length has a direct impact on how effectively the model interprets instructions. This leads us to another key concept: finding the balance between prompt detail and prompt efficiency. At first glance, it might seem that longer prompts should always produce better results because they contain more information and guidance. In reality, the relationship between prompt length and performance is more nuanced. Both excessively short prompts and excessively long prompts can reduce performance. Very short prompts often lack sufficient context. When the model receives minimal information, it must infer many aspects of the task. These inferences are based on general statistical patterns, which may not align with the user's intention. As a result, short prompts sometimes produce outputs that are generic or partially misaligned with the task. On the other hand, extremely long prompts can introduce a different problem. When prompts contain large amounts of text, the key instructions may become diluted among less relevant information. The model must distribute attention across all tokens in the prompt, and if critical instructions are buried in the middle of long paragraphs, their influence on the output may weaken. Another issue with long prompts is the risk of conflicting signals. The more instructions included, the greater the chance that some of them interact in unintended ways. A prompt might simultaneously ask for conciseness, detailed explanation, creative examples, and strict technical language. Each instruction pushes the model in a different direction, and the resulting output may reflect a compromise rather than a precise response. Finding the sweet spot in prompt length involves providing enough detail to eliminate ambiguity while avoiding unnecessary verbosity. The goal is to include the information that directly influences the task and exclude information that does not contribute to the desired outcome. One practical guideline is to prioritize clarity over completeness. A prompt does not need to describe every aspect of the task in exhaustive detail. Instead, it should focus on the elements that the model cannot reliably infer on its own. These elements typically include the objective of the task, the desired output format, the intended audience, and any critical constraints. Another useful strategy is to place the most important instructions near the beginning of the prompt. Because the model processes text sequentially, early tokens play a significant role in shaping the generation process. When key instructions appear early, they establish a strong contextual signal that guides the rest of the response. Prompt structure also plays an important role in balancing length and performance. Well-structured prompts separate instructions, context, and examples in a way that makes their roles clear. This structure helps the model interpret the prompt more effectively. Examples, when used, should be carefully chosen. A few high-quality examples can dramatically improve performance by demonstrating the desired pattern. However, too many examples can increase prompt length without adding additional clarity. The best examples are those that illustrate the exact transformation the model should perform. Another factor influencing prompt effectiveness is cognitive load within the model's attention mechanism. Language models allocate attention across all tokens in the prompt when generating each new token. As the number of tokens increases, the model must distribute its attention across a larger context. While modern models are capable of handling long contexts, attention is still a finite resource. Prompts that contain large amounts of irrelevant information consume attention capacity that could otherwise be focused on the task. This is why experienced prompt designers often refine their prompts iteratively. The first version may include many explanatory details. Through experimentation, unnecessary components are removed until the prompt becomes both concise and effective. Prompt length also interacts with output quality in subtle ways. Longer prompts sometimes encourage longer outputs because the model mirrors the verbosity of the input context. Shorter prompts may produce more concise responses. Understanding this relationship allows prompt designers to influence the length of the generated text indirectly. Another important consideration is maintainability. In production systems, prompts are often embedded within software applications. Extremely long prompts can become difficult to maintain, update, and debug. Concise prompts are easier to modify and test. The idea of the sweet spot in prompt design is therefore not a fixed rule but a practical balance. The prompt must contain enough information to guide the model accurately while remaining focused and efficient. Achieving this balance often requires experimentation and observation of the model's behavior. When tone control and prompt length optimization are combined, prompt engineering becomes a form of interface design. The prompt acts as the interface through which human intention is translated into model behavior. Every word in the prompt contributes to that translation. Experienced practitioners begin to think about prompts the way software engineers think about APIs. The prompt defines the contract between the user and the model. It specifies what the model should do, how it should communicate, and what form the output should take. Through careful control of tone, style, voice, and prompt length, engineers can transform large language models from unpredictable conversational systems into reliable tools capable of producing consistent, high-quality outputs. This process does not rely on secret techniques or hidden tricks. It relies on understanding how language models interpret textual context and designing prompts that align with those mechanisms. When prompts are written with clarity, intentionally, and structural discipline, the model's probabilistic generation process becomes far more predictable. As a result, the practice of prompt engineering gradually evolves from experimentation into a systematic discipline. Practitioners learn to recognize which aspects of a prompt influence tone, which elements guide reasoning, and which structures enforce output consistency. With experience, prompt design becomes less about trial and error and more about deliberate communication with a complex statistical system. In this sense, controlling tone, style, and voice while maintaining an optimal prompt length is not merely a cosmetic improvement. It is a core component of making AI systems useful, reliable, and aligned with human expectations in professional environments.
If you find this video exciting, please like, subscribe, and turn on notifications. See you in the next AI for Beginners educational video.